Thank you, Nobu, and thank you very much, Kim and Veronica, for this incredible honor to give this lecture. Now, I'm going to assume that after yesterday, the demand for jokes has been abundantly satisfied, as well as the demand for choral conducting, other forms of musical entertainment, dancing. And so I won't do any of that and go straight into my topic, which is technology. And in particular, what is the nature of technological change, variation in technology over time? What's the nature of technology differences across countries? And most of the time, when we economists think about the nature of technological variation, we instinctively go to a world where technological change or technology differences are parallel shifts in the isochrones. So that if we say use capital 5% more efficiently, we then also use labor 5% more efficiently, and all other inputs 5% more efficiently. In other words, we treat technological change and technological differences most of the time as neutral with respect to the factors of production. So when people say things like, I'm going to put a TFP shock in my business cycle model, or when they say country B has twice as large a TFP as country 1, that implicitly in that there is an idea of neutrality of technological differences. Now, of course, there are cases, there are exceptions where we economists are happy to go to a non-neutral with respect to factors notion of technology. Eric last night alluded to, maybe he didn't use these words, but alluded to skill bias technical change, essentially, which is the idea that over time, the efficiency units delivered by skilled workers change differently from the efficiency units delivered by unskilled workers. And that's been very successful, I think totally appropriate, and one element, as Eric explained, in understanding big changes in labor markets over the last several decades. But I would say that in general, these specific applications of non-neutrality are a bit peripheral, and the central vision of technological variation, technological change, technology differences remains one where these variations are factor neutral. And so what I'm going to try to do tonight is to try to bring non-neutrality a bit more towards the center of our way of thinking about technology and technological change and technology differences, and try to argue that, in fact, non-neutrality is a much more pervasive phenomenon. I went as far as to call it an ubiquitous phenomenon in the title of my lecture, than it would be, than you would tend to expect given the centrality of the neutral approach or the neutral way of thinking about technology differences. So in particular, one element where, one dimension in which we see this, for example, is skill bias technical change is not only over time, is also across country. Skill bias also visible across country. Is not only visible between skilled and unskilled labor. You can see non-neutrality between different cuts of the labor force, for example, between experienced and inexperienced workers. It's visible inside the aggregate capital input, and so there is non-neutrality between different types of capital goods. And it's also visible when you compare an aggregate of all the labor inputs and all the capital inputs. Even there you see evidence of non-neutrality. And so that's what I mean by saying it's ubiquitous. Basically, everywhere I've looked, I found non-neutrality. It's not only ubiquitous, it's also non-random. The patterns of non-neutrality that I think the data show us are actually surprisingly easy to rationalize, even though they are so different and across many different cuts of the inputs in the production function. They are actually quite easy to rationalize with a very simple theoretical framework of technology choice by firms. So ubiquitous and non-random, easy to rationalize. And therefore, I would argue, perhaps easier to, when we come out of it at the end of this short journey we took through non-neutrality, I think I would argue perhaps to take a more central place in our thinking about how technology varies, not only across countries, but also over time. So that's going to be my claim or my argument tonight. So we talk about technology, so we're talking about production functions, obviously. And so that's the object that is at the center of the discussion tonight is an aggregate production function, which maps, of course, inputs into outputs. There are subscripts there, which are C for country, T for time, because I want to think both across countries and over time. And of course, at the most general level, even the functional form, the mapping between inputs and output, also has country and time subscripts, because that's the whole point of technological change and technology differences, that this mapping could change both over time and across countries. So that's the general expression of it. Now, what do we do most of the time? And I say we because I've done it as much as anybody else in this room. We go straight to the second formulation, where essentially we assume that there is a country invariant and time invariant aggregator of the inputs. And then the time variation and country variation in the technology is essentially given by this multiplicative term that comes out. And we call changes over time technological progress, and changes across countries, we call it typically TFP differences across countries. Now, of course, this is not, of course, far from me from criticizing this. This has been useful in a million ways. But of course, if that's the starting point, we cannot even start talking about non-neutrality, about technical variations that affect different inputs differently. And so what's the minimum step to go from the second line to somewhere where we can talk about non-neutrality? Something along these lines. So still incredibly restrictive compared to a completely unrestricted form of variation in technology across countries. There's still this country invariant and time invariant aggregator. However, we allow technological change to affect different inputs differently. So with this formulation, at least, we can entertain the possibility that, say, if the efficiency with which you use factor 1 goes up by 5%, the efficiency with which we use factor 2 does not need to go up by 5%, it could go up by 2%, by 0, it could even decline. And so that's kind of the world in which I want to be today. Now, when we use the second line here, the second expression, the factor neutral one, what do we very often do? Well, typically what we do, we pick a functional form for the G tilde aggregator, or at least put restrictions on the G tilde aggregators. Then we measure the inputs, x1, x2, we measure the output y, and then we back out the A as a residual. And so what I want to talk about tonight is methods to try to do something a bit similar with the last expression, where again, there's going to be a functional form choice for G, and then there's going to be measurement of inputs, measurement of output. It will turn out to be very important to measure also factor prices. And once that is done, you can try to say things about how the A's vary and how the ratio of the A's vary. So I said you need to make a functional form assumptions. This is my functional form assumption. All right, so I'm going to have a top level, which is a CES aggregate of capital and labor. And this CES aggregate of capital and labor is governed by the residual substitution, which in this case is going to be 1 over 1 of sigma. And I'm going to have these efficiency parameters, AK and AL, that are a big part of my object of interest. Then under this top level, I have a breakdown of the labor input and a breakdown of the capital input. The breakdown of the labor input is a very standard one. You've seen it a million times. It's the standard one between skilled and unskilled labor. No more needs to be said about it. The residual substitution is 1 over 1 and rho. Again, there is an AU and an AS in which I'm going to be interested. Now, the unpacking of the capital input is probably much less familiar. It's an unpacking where I'm looking separately at natural capital and reproducible capital. So natural capital is things like timber resources, subsoil resources like minerals, agricultural land, all the stuff that you naturally, instinctively associate with the word natural capital. And the reproducible capital is the much more well-known machinery and equipment. Now, why do I look at that natural capital and reproducible capital breakdown? Why do I think it's interesting? Well, there is some other work I've done in the past on related but different questions that convinced me that not taking into account of the fact that natural capital is a very big chunk of the capital stock in poor countries, which it is, it can lead to significantly misleading inferences, for example, on things like development accounting or questions about the marginal product of capital, whether it's different across countries or it's the same across countries. So, and just the fact that it's so prevalent as a share of the capital stock in poorer countries makes me think that it's important to also look at that. So this is going to be my production structure. The reason for the functional form assumption, as you can guess, is purely convenience in terms of the data I have available and in terms of which kind of nestings of these inputs do I have some information about the parameters, particularly the parameters that govern the substitution, that allows me to make some inferences about technological change and the A's more general. So there are 6 A's here, as you can see, and I'm going to be interested in 6 A's. Now, given the functional form, I can be more specific about the language I will be using to describe non-neutrality and the nature of the non-neutrality. How does non-neutrality, if it's there, how does it work? How will we describe it? So obviously, if you start out with this production function, the CES framework, for any 2 inputs that belong to the same level of nesting, you can immediately very easily write down the ratio of marginal products of those 2 inputs. And that ratio depends on 2 power functions. One is the power functions of the relative supply of the 2 inputs. That's a very standard, that's economics 101. Given decreasing marginal products, if you increase the relative supply of one input, of course, you reduce the relative marginal productivity of that input. Of course, the exponent on this power function is negative. The other power function is a power function of the ratio of the efficiency units delivered by the 2 inputs, A1 and A2. This power function could be increasing or decreasing depending on whether the substitution is greater or less than 1, i.e. zeta is greater or less than 0. And this is where any factor bias, if there is a factor bias, will show up. And in particular, you see here that changes in the power function of the efficiency, or the ratio of efficiency units, changes the relative marginal productivities of the 2 inputs, even holding constant the relative supply of the 2 inputs. And so that's the notion of factor bias, and I will call this a factor, so this pointer doesn't, I don't know if you read, but I'm going to call this term here the factor bias term, because it describes the bias in technology towards one or the other of the factors. Okay, so I'm not going to call any random variation in this factor bias term evidence of non-neutrality. I want to see systematic variation in this factor bias term before I say there is non-neutrality. So what would constitute systematic variation in the factor bias term? Well, one thing is if there is a time trend, right? If there is a long-run time trend in the factor bias trend. If I see a long-run time trend, then I say, well, yeah, that there is non-neutrality in technological change. And in particular, the language I'm going to use, if I put factor 1 at the numerator here, I'm going to say that if the trend here is positive, I'm going to say technological change is biased towards factor 1. If the change is negative, technological change is biased towards factor 2. What I'm going to do about it across countries? What's going to be systematic evidence of non-neutrality across countries? Well, I'm going to do something very similar. I'm just going to switch the time indicator with a GDP per capita indicator. Okay, so I'm going to say that if the factor bias term is high in rich country, technology differences are biased towards factor 1. If the factor bias term is high in poor countries, then technology differences are biased towards factor 2. Okay. So that's just a way of just language, to agree on a language to describe the non-neutrality. And if I don't see trends over time, or if I don't see systematic correlations with income, then I'm going to say, well, it looks pretty neutral. Okay, given that, let's have an overview of, basically, this is what I think the data are telling us about non-neutrality across countries and over time. So the first bullet point is what we already know. And so, in particular, if you start from the top right here, that's just skill bias technical change. Okay, so we've known it for 20 years, it's there. Now I've done a lot of work to check in other countries, many other countries over time, it's there, it's everywhere. is there, we know it's there. In fact, I'm going to say from the get-go, I'm not going to spend any time on this because I take it as read that we all know this, all right? Now, one thing I'll talk about a bit more is that it's also visible across countries. That's, admittedly, that's also kind of old, but it helps me a lot to set up the stage for the other things that are newer. And so it's true that the same way that it's true that the skill bias factor has been increasing over time, you also find that in rich countries it's much higher than in poor countries. Okay, so what's the perhaps newer stuff? One thing that is also seems to be there is a reproducible capital bias. Okay, so if you go look across countries and you put the reproducible capital in the numerator, you find a bias towards the reproducible capital. So the reproducible capital, the factor bias factor for the reproducible capital is higher in rich countries. And then, perhaps more importantly, there is also quite strong capital bias. Okay? In other words, if you define the factor bias terms with capital numerator, labor denominator, then the factor bias term is high in rich country, and is increasing over time. Okay? And so what we all know is happening for skilled and unskilled labor is also happening much more broadly. And in fact, I won't really talk about this because of lack of time, but in fact there is yet another, I have this theme of ubiquity, there is yet another cut where if you break down the skilled labor input into experienced and inexperienced, and the unskilled labor input into experienced and inexperienced, and look within these two subgroups, you also can find evidence for experience bias. So that's another dimension that kind of comes out. Now, this is my overview of the kind of what the data I think says. It's also an overview of my, also acts as an overview of my talk, because I'm going to go through these things. I also show you something else. For the top level of the production function, the one between capital and labor, you're actually not limited to the factor bias term, which is a relative of the two efficiency units. You can also look at the absolute pattern of the efficiency term for capital and labor. You cannot, I explain why you cannot do it for the lower levels, but you can do it for the top level. And so I can ask, how does the absolute level of the A and the AK vary across countries? Now, if you look at what the AL turns out to be, it's exactly what you expect from a lifetime of working with neutral technological change, neutral TFP difference across countries. That is, it's much higher in poor countries, big yawn there. However, when you look at the efficiency with which capital, the efficiency unit delivered by capital, it's not at all like that. In fact, if anything, it's decreasing with income per worker, and it's decreasing over time. And that's very, very different from what a lifetime of working with neutral models of technology variation would lead you to expect. It's actually so different that I'm sure that half of you, or maybe 3/4 of you, think I'm completely mad, and it cannot be right. But if you are patient and you allow me to get to the last 5-10 minutes, I'm going to try to show you that actually you can write down a very simple, I think very sensible model of technological choice that has precisely this implication. And so hopefully we'll not look so mad after we get there. Right, so that's the plan. One last thing before we get to the data, the method. Okay, how am I going to draw inferences about the factor bias term, both over time and across countries? Well, let me go back. This is the same equation I put up before of the ratio of marginal products as a function of relative supplies and relative efficiency units. Now, I'm going to add one assumption. The assumption is that factor prices equal marginal products, at least approximately. That means that I can rewrite that equation in terms of as an equation for relative factor prices. So what's my method to back out the factor bias parameters? I'm going to try to measure factor prices, relative factor prices, both changes over time and across countries. I'm going to try to measure relative factor supplies. I'm going to calibrate the parameter, the elasticity substitution, and hence the zeta parameter. And then I'm going to back out the factor bias term as a residual. Those of you who know Caselli-Murphy, this is Caselli-Murphy. Okay? It's basically the Caselli-Murphy idea. All I'm doing is I'm just generalizing it to a cross-country context, and I'm also applying to other pairs of inputs, not just skilled labor and unskilled labor, but also natural and reproducible capital, capital and labor, experience and experienced worker. But it's basically the Caselli-Murphy idea. I'm just going to apply it repetitively in many different settings. All right, so that's the plan. So let's get going. And that's my methodology. So just let's write that down for my first application, which is the skilled and unskilled labor. I repeat, I'm not going to say anything about the overtime variation. I just can tell you, you can take all the more recent data is still there. It's big. It's everywhere. Big skill bias technical change over time. Let's not revisit things that I've already well established. What about across countries? Again, this is actually kind of old, but I think I want to put it all in the same big picture with the other things because I think it's useful to see everything together. So that's my method, again, is to measure relative factor prices, in this case, the skill premium, the relative wage of skilled workers compared to unskilled workers, and of course depends on factor supplies and then my factor bias term. All right? Now, again, I have limited time, so I'm not going to go in any detail into the construction of the relative supply of skills or in the construction of the wage premium. I'm just going to give you a very impressionistic pointers of how I do it. I promise you it's not controversial. So for skilled and unskilled labor, I'm going to take the Barrow and Lee data, inevitably, which divides the labor force into many different schooling attainment groups, from zero schooling to some primary, from primary completed and so on. And at least for my baseline, and one thing I'm going to tell you, let's take it as given that I've done a lot of robustness checks for the things I'm going to tell you, and you just trust me on that. So as a baseline, I'll have everybody with high school completed and less being unskilled, everybody with above that being skilled, and let's further weight people within these categories by relative wages. So that, for example, a college graduate contributes more to the skilled labor input than a college dropout, say. And that's going to be basically my measure of the relative supply of skills. About wage premia, it's a bit more involved. The first step is to construct a big data set of ministerial returns from many different countries. And then there is a mapping. If you have the ministerial returns, if you have the groups of people going to different education levels, if you have the duration of schooling or different education levels, you can actually reverse, invert the ministerial return and recover a skill premium. So that's how I do that. So that gives me a skill premium. The Barrow and Lee gives me the relative supply. What about the elasticity substitution? Remember I told you three things I need, the supply of factors, the relative wage, and the elasticity substitution. What about that? Well, here we are in a fortunate situation because the elasticity substitution between skilled and unskilled labor happens to be one of those elasticity substitution over which there is broad consensus. Okay, so most people think it's about between 1.4, 1.5. My favorite estimate is 1.5 because I think that comes from the best identified IV strategy to estimate that. So I'm going to use 1.5. Again, the results are quite robust to that. So I told you my three ingredients, and so I have everything I need to back out my factor, my skill bias term. Before I show you the skill bias term, let me show you the raw data, the input that goes into this calculation. So this is the relative supply of skills across countries. So I have two years, 1995, 2005. And this is plotted against income per worker with a log scale. So what you see here is what you would expect. That is the relative supply of skills is much higher in rich countries. I mean, the gradient here is very steep, and rich countries have much more skills than poor countries. That's exactly what you would expect. That's the relative supply of skills. That's one ingredient. Remember, the other ingredient is the wage premium. Okay? How does that vary with per capita, with per worker GDP. Well, it's a funny thing. So this is it. This is skill premium. And if you stare at it long enough, and perhaps more to the point, if you try to fit a regression line to this data, it's actually downward sloping. Okay, so it is what you would expect qualitatively. So it is higher in poor countries, it's lower in rich countries, which is, I think, what we all expect. But keep in mind, it's going to be very important for what comes next. This gradient is very gentle. Okay, the slope is very flat. Okay, it's downward sloping, but it's very flat. All right, I'm going to come back to that in a minute. So I have my two ingredients: the relative supply, the skill premium, and this is my skill bias. Okay, this is the residual term, which I back out from as a residual. Now this is clearly upward sloping, and in fact, if you look at the axis, the gradient is very, very steep. Okay, so it's much, much higher in each country. So in rich countries, the factor bias for skilled workers is much higher, much higher than in poor countries. So this is my extension of the skill bias technical change result to the cross-country context. Now, it's going to be very useful for me, for what comes next, to explain how does this result come about? Why does the data tell you that there is this strong skill bias? I think many of you probably already gotten it, but just to be all on the same page. So let's think about why I get this strong skill bias across countries. So here I'm plotting the same original data, the wage premium and the relative supply of skills. Before I plotted that against per capita income or income per worker, here I'm plotting them against each other. So I have the skill premium on the vertical axis, I have the supply of skills on the horizontal axis. All right? Now, the green line here answers the following question. What would we expect the gradient of the wage premium if there was no skill bias? Okay? If the term in the relative efficiency unit was constant across countries. In other words, this is what we should observe if all the variation in wages was driven by relative supplies. Okay? Well, we know, remember the expression for the skill premium we had before. There are these two power functions. Okay? Take logs, and it turns out that it takes logs. You get the relationship at the bottom here. That you should just get a downward sloping relationship with an elasticity of rho minus 1. Okay? So that's a very steep downward relationship. Now, the dots are the data, and the red line is the fitted line through the data. Okay? So in other words, what this is saying is that the skill premium doesn't decline with the relative supply of skills nearly fast enough as you would expect given how much more skilled workers rich countries have. And so there must be something that is counterbalancing the effect of the decrease in marginal product of skilled workers. What is that thing that counterbalances is the factor bias in efficiency, is the factor bias term. Okay, so why doesn't the skill premium fall so much? Well, because rich countries, yes, they have all the skilled workers, but they also use the skilled workers much more efficiently. So that's kind of intuition. It's going to come back. Again, it's going to be very useful in a minute. Okay, so that's what I have to say about cross-country. So let's move to other stuff. So I told you that another level of nesting I'm interested in is looking within the capital stock and the relative efficiency of natural capital and reproducible capital. So let's write down the same equations as before, which expresses the ratio of marginal productivities of these two capital types as a function of the relative supplies and the factor bias term. It's the same expression as before. And once again, let me not spend much time at all on describing the data collection procedure because I don't have the time to do that. So let me just say very briefly that the relative supply of reproducible capital, remember M is reproducible capital, N is natural capital. So the composition of the capital stock into its natural and reproducible capital actually exists in a data set generated by the World Bank, which has been at it for several years now, and they provide this data. Okay, so I'm taking just straight from the World Bank. Now, for the ratio of marginal products, it's a bit more complicated, but it turns out that the same data from the World Bank also has data on the shares in GDP that accrue to different types of capital. And you combine that with some national account identities and the assumption that factors are paid the marginal product, and you can back out from the data on the shares paid to different types of capital, you can back out the ratio of marginal products of the two types of capital. So that's where it's coming from, and I'll skip on the details. So how do these things look? Well, I already told you more or less how it looks for the reproducible to natural capital relative supplies. Rich countries have a much larger relative contribution of reproducible capital to the total capital stock than poor countries. In poor countries, natural capital is much more important. In rich countries, reproducible capital is much more important. So that's pretty much what you would expect, given that these countries are largely agricultural, largely primary resource dependent, and so on. Now, what about the marginal productivities? Well, it's more clearly downward sloping than before. It is the case that the countries with a high relative supply of reproducible capital have a lower relative marginal productivity of reproducible capital, as you would expect. But once again, it's striking how the gradient is modest compared to how steep it is for the relative supplies. I think you already know where I'm going. Now, at this point, having put up the data, remember my methodology is to then pick a value for the elasticity substitution between these two inputs, and then back out my residual factor bias. Unfortunately, I'm not quite in that position here for the simple reason that I'm not aware of, and I'm pretty sure it doesn't exist, an estimate, reliable or not reliable, of the elasticity substitution between natural and reproducible capital. However, I can make qualitative statement, okay? I cannot produce a quantitative estimate of the factor bias, but I can produce a qualitative statement about it. And my qualitative statement is this one here, and it's the following. As long as you're prepared to accept that the elasticity substitution between reproducible and natural capital is less than 3, then, at least if you believe the data, you have to conclude that there is a bias toward reproducible capital across countries. And the intuition is very much the intuition I gave you for the skill bias before. Okay? The relative supply of reproducible capital increases massively as you increase income per worker, but the relative marginal productivities decline only gently. Any elasticity substitution less than 3 would lead you to expect a steeper decline of the relative marginal productivity of reproducible capital. So you have either two options. One option is you accept that there is reproducible a factor bias toward reproducible capital, or you believe that elasticity substitution exceeds 3. Only if it exceeds 3, you can reconcile the only gentle patterns of decline of the marginal productivities, relative marginal productivities, given the change in relative supplies. Now, one way to think about this is that to remember that the elasticity substitution between skilled and unskilled labor is 1.5. So what you have to believe to resist the conclusion that the factor bias is toward reproducible capital is you have to believe that natural reproducible capital are more than twice as substitutable as skilled and unskilled labor, which doesn't seem, introspectively, doesn't seem plausible at all. In fact, my all introspective guess would be that, if anything, they're going to be less substitutable than skilled and unskilled labor. So that's the basis for the factor bias between reproducible and natural capital. Let's go up one level. Let's look at an aggregate of capital and an aggregate of labor. You'll notice that there has been a little bit of change in notation here. I have these tildes have sort of kind of surfaced. I didn't have tildes before. I have tildes now. The reason is that in order to turn to make this L object, this K object observables, I have to move some unobservable stuff out of the K and L term and put them into the A term. So I have rewritten basically that production function in K and L, in which the K and the L had unobservable terms in them. I move all the unobservable into the A tilde and the A tilde K and the A tilde L terms. And now, given the results I had before, I can measure the K tilde and the L tilde. But the interpretation is very similar. It's not worth really going into the details because the interpretation is very, very similar. So I can still interpret the AK, in particular efficiency units associated with the capital, and the AL as efficiency units associated with labor. All right, so what do we do when we write these things? What have we done so far? Well, after writing this production function, the first thing we've done is to take marginal products and equalize to factors of productions, which I'm doing again here. And then what we have done in the previous two cases is take the ratio of this expression and then write it in terms of the ratio of the A's. Now, it turns out that here I can be a bit more ambitious because this term YC here is, of course, observable, is income per worker. Okay, so in the other two cases, the term there was unobservable, so I couldn't do much with the absolutes. But because YC is observable, I can actually try to use directly this equation to say something not just about the ratio of these two things, but actually how the absolute value varies across countries and over time. And in particular, I can solve out those two expressions for the efficiency levels, for the efficiency terms of labor and capital, as functions of two objects that are measurable. One is the share of that factor in GDP, and the other is what I will call the average product of that factor. And the last term is particularly easy to interpret. If you see a high average product of that factor, it's a good sign that that factor is used efficiently. I still have a big problem, which is sigma. Okay, so again, sigma is another of those parameters where that not only me, but everybody would love to know exactly what it is, but we actually don't know. What we almost certainly know is that it's less than 1. Okay, but whether it's very close to 0, very close to 1, we don't really know. Now, so that it seems like I'm stuck, but in fact, I'm in luck again, because it turns out that these shares in GDP don't vary very much with GDP per worker, with income per worker. Okay, so for example, this is the labor share plotted against income per worker. It's all over the place, of course, but it doesn't systematically seem to vary with income per worker. So remember, my question here, when I write this down, is to ask, is there a systematic pattern of variation of the A's with income per worker? Well, if the share these two share parameters don't vary systematically with income per worker, that tells me that this term here will not affect the systematic patterns of variation of the efficiency term with income per worker. Okay? In other words, I can be very bold and just say, you know what? As a first approximation, when I'm looking at the correlation with GDP per capita, I'm just going to set that to a constant and just look at how this term here, which for my luck doesn't depend on sigma, how does that vary across country? Okay, and so I'm just going to ask a very simple question. And then basically I reduce. I don't equate the A with the average productivity, but I'm saying that the A in a cross-country profile is proportional to the average productivity of that factor. Okay, and so how does that look? Well, this is the efficiency of labor across country. So this is Y over L across country, and it's steeply increasing. Okay, so this is completely just out of the TFP world where rich countries do things right and poor countries are hopeless and do everything wrong. But then you do the same thing for, do the same for capital, and you find, and again, you know, you look at it long enough and you detect, if anything, certainly not an upward sloping pattern and possibly a downward sloping pattern. And if you run a regression line, it's significantly negative. So actually lower AK in rich countries than in poor countries. Okay? So now, how can that be? How can it be that this rich country that we are so used to think they're doing everything right, how can it be that they are less efficient users of capital? And so here, and I have a little bit time left, I want to, sorry, before I do that. So I done the efficiency, so I find the absolutes. Let me complete the picture of factor bias terms, okay? So there is still a ratio to look at, which is the ratio of the AK to AL to the sigma, my factor bias term. But you can immediately see what that is, right? So AK is decreasing with income, AL is increasing with income, and we know that the zeta substitution is less than 1. We know that, and which means that sigma is less than 0. And so this thing here must be increasing. So that's the capital bias result. That's the fact that the factor bias, when you put capital denominator, is increasing in income per worker. Okay? So that's the overview of the empirical patterns. And so let me try to rationalize these things for you. So the starting point is to think about technology choice. And the idea of technology choice is that when you decide to produce something, there are many, many recipes with which you could produce it. All right? So, you want to make cars, and you could do it with robots and super skilled engineers, and then maybe some janitors. Or you could do it with an assembly line and workers using hammers, and maybe the skilled guys, all they do is to make sure that the workers in the assembly line don't take too many breaks. And many other ways of producing. All right? And if you think about that, it's plausible to think that these different menus, these different recipes, will come with different efficiency units associated with the different inputs. So if I use the engineers and the robots, maybe I'm going to have a high A for the high-skilled workers and maybe a low A for the janitors. But if I put the unskilled workers to the assembly line and I keep the engineers just checking that people don't take too long breaks, then maybe I'm going to have a low A for the engineers, for the skilled workers, and a high A for the unskilled workers, and so on. And you can come up with many examples. So in general, I like to think about technology choice as a choice of a point in the A1, A2 space, in the space of possible combinations of A1 and A2. So there is I imagine there is this bookshelf, and from this bookshelf I take out blueprints, and each blueprint basically is a pair of A1 and A2. And they're going to be like this. There are going to be some really crappy ways of doing stuff down here. There are going to be some good ones up here. And in general, there's going to be what I call a frontier of blueprints that are not dominated, that are, that you cannot improve the efficiency of one input without lowering the efficiency of another. So that's the kind of world I want to think about, which I think is a plausible world to think about. And then in this world, I want to put firms in this world, and I want to tell firms, look, you're not going to choose only how much skilled workers, how much unskilled workers, how much reproducible capital, how much natural capital you want to hire. You also have to choose a combination of A's. And obviously, you're going to choose from the frontier. All right? So I'm going to think about this problem here. So the profit function is the standard one. It's the one that we write all the time. But I'm also maximizing over A1 and A2. And I also saying your A1 and A2. And here is the frontier. Here is the menu of choices. Okay? So that's all I'm saying. And of course, this is a very static version. There are much more beautiful, much more dynamic versions. Daron has written dynamic versions of this that are obviously much more sophisticated. But again, with the flavor that, and the results are going to be a very similar flavor. And so what a model like this, you have to make, okay, so what are the other assumptions? So the assumption that the firms are price takers of factor prices, but the endowments of factors are given at the country level, and you solve for the general equilibrium. And so in general equilibrium, the choice of technology will depend on the factor endowments of the country, okay, mediated through the factor prices. And so a model like that actually gives you a very simple, very simple answer, which is that technology is biased towards the abundant factor. Okay, is that the term we call the factor bias term, this power function of the relative efficiency units, is biased towards the abundant factor. That's what this model says. And so how does that do against the facts that the patterns we looked at? Okay, we saw skill bias. Skill bias is there is a factor bias towards skilled labor as you move to higher income. Well, rich countries are much abundant in skills. So that checks. There is skill bias in the data, exactly like the model would predict. What about reproducible capital bias? Well, we saw that there is a bias toward reproducible capital, meaning that the factor bias term for the reproducible capital is high in rich countries. But we also saw that rich countries have abundant reproducible capital compared to natural capital. So that checks. We saw that there is a capital bias, meaning that if you look at the factor bias term with the capital denominator, labor denominator, that term is higher in rich countries. But rich countries have abundant capital compared to labor. So that also works. Okay, so those patterns are consistent. It's not in the slide, but also the experience bias thing is consistent. So this part is all lines up with this extremely simple framework for thinking about technological choice. What about the absolute changes in efficiency unit of labor and capital? Well, so what does the model says for the patterns of the efficiency unit? Well, if the residual substitution is less than 1, the technology choice model says that your efficiency, the efficiency with which you use one input, declines with the abundance of this input. And the intuition is very simple. If the two inputs are fully substitutable, you want to boost the effective supply of the scarce input. And you don't care so much, and you're willing to sacrifice the efficiency with which you use the abundant input in order to boost the effective supply of the scarce input. And so that, when you look at the prediction for the absolute efficiency, you predict that the efficiency with which you use capital decreases in capital abundance, which is exactly what the data say, because rich countries are abundant in capital, and AK falls as you move towards rich countries. And of course, the correlation between AL and the capital labor ratio is positive, because, again, rich countries are relatively scarce in labor, so they want to boost the efficiency of labor. So again, also these absolute things check. And so that's the basis for my hope that you will find my results on declining efficiency of capital a little bit less implausible after seeing this. This is over time, just to complete the picture. Labor efficiency increasing, capital efficiency actually even more clearly decreasing over time than across countries. And so to my conclusions. So that's kind of you can recognize this slide. This was my initial overview. So I didn't talk about this, but that's because we all know that. And we talked about these other things. Again, some of them are old, some of them are new. I just thought it would be useful to put them all together. And I didn't talk about the experience bias, but just to return to this, there seems to be a bias towards experienced workers over time. And that is with a way to, again, reconcile variation in experience premia with changes in relative supply of experienced workers. Okay, and then of course, there are these other results on the changes in the absolute efficiency with which capital and labor are used. So the bottom line, I just repeat what I said at the beginning. There is, I think, a lot of non-neutrality popping up everywhere. And I think it's a non-neutrality that makes sense. That if you write down the simplest way of thinking about technological choice is the kind of neutrality you would expect to find. But if that's the case, if this neutrality is so natural and so logical and is there everywhere in the data, then perhaps non-neutrality should be more at the center of the way we think about technological change. Thank you very much.